Welcome back to part 2 of the Trig video 2.1 and pre-calc video 5.1. We're going to continue to use the formula sheet to help us simplify identities. And in this next example, I'll notice that I have the identity cotangent 90 minus x, and I'm timesing that by cosine. A lot of what I'm trying to do here is I'm trying to look at that formula sheet, make some sort of substitution into my problem, so that I can reduce my problem down to one trig identity. There isn't really a list of things that I can say, do this, this, and this, and you'll have your final answer. And if you do it in this order, followed by this, then thirdly do this, you'll get the correct answer. But what I have done is kind of come up with probably what I would say the 5 most common things that you want to try to do to help you to solve these. So let's go over those steps. 1 is factor if possible. 2 is changing all of your identities into either a sine or a cosine, because you'll notice on the formula sheet those are the identities that we have the most of. And if we have the most of those, it's very likely then that by plugging a sine or a cosine into your problem, you're going to be able to get it to reduce down to something else. Simplify if possible. If you can simplify right away, go ahead and do that. Split into fractions or combine fractions. So if you can, try to change something into 2 fractions being added together or subtracted from each other. Or if you do have that already, 2 fractions being added or subtracted, try to actually add or subtract those from each other and get 1 fraction. And then again, we always want to try to have our answer be only one trig function when we're all done. So as I look at this one, at this example here, what I'm noticing is that this cotangent of 90 minus x is a cofunction identity. So I'm looking at the cofunction identity of my sheet, and I notice right here I've got that same thing. Now on your sheet it's given to you in radians, but understand that this pi over 2 is the same as 90. So this is really cotangent of 90 minus x. And what we're saying that cotangent of 90 minus x is, it's the same thing as the tangent. So I'm going to replace all of that with just the tangent. So now it becomes tangent times the cosine. I'm going to go back to my formula sheet and I'm going to try to find some sort of identity for tangent. Now since I already have a cosine in my problem, I'm going to want to try to do this. I'm going to want to change it into a sine or a cosine if possible. Well, I know that there's the tangent identity out there that says that tangent is the sine over the cosine. So if I change tangent into that, what will happen when I multiply by the cosine is that this is really cosine over 1. These will cancel out and I'll be left with just the sine. And so I was able to take these 2 identities multiplied together and change it to just one identity, which is the sine. So again, I'm going to use that formula sheet to find an identity that will work, that I can make a substitution into, and then I'm going to try to do any of these steps that I possibly can. Okay, looking at our next identity here, we have the sine squared times the secant squared, and we're going to subtract the sine from it. So if I look at the 5 steps that I've suggested that you follow, the step 1 is to factor. And what I notice about this problem is I can pull out the greatest common factor, which is equal to a sine squared. So I'm going to do that. I'm going to take out a sine squared, which means I'm going to divide this by sine squared, and I'm going to divide this by sine squared. So what will happen is the sine squareds will cancel out. I'll be left with secant squared minus the sine squareds cancel out again, and in this case I'm left with just a 1. Okay, now I'm going to try to make some sort of substitution. I'm going to go over to my identity sheet here, and I see that I have secant squared minus 1. Well, secant squared minus 1 is right here, and that's what the tangent squared is equal to. So now my problem becomes sine squared x times tangent squared x. Very similar to what I had before. In the previous problem I had a tangent, and I changed it to sine over cosine. This time I have a tangent squared. So one of the things I want you to add to your formula sheet is with the tangent squared and the cotangent squared, you can actually write it as tangent squared of x is equal to the sine squared over the cosine squared, and the cotangent squared of x is equal to the cosine squared over the sine squared. So you can actually take both of these identities and square them. If you have it squared, you cannot take the square root. You can't work backwards. So these are two identities I want you to add right next to the tangent portion and cotangent identities on your formula sheet, because if you don't add it to your sheet, you tend to forget about these. So the tangent squared, I'm going to use the identity that we just wrote here, is the same as the sine squared over the cosine squared. Drop down this sine squared. Now this time I don't get anything to cancel out. But instead of it being two identities that I'm multiplying together, I can make it just be one answer here, which if I multiply these together, I get sine to the fourth over cosine squared x. And I can't do anything else with that. I can't change it into tangent or cotangent, so I'm just going to leave that as my answer. So it's not always 100% true that I'm going to be able to factor this down, reduce it, consolidate it, simplify it, so that I get just one trig function. In this case I get two, but that's as far as I can take a problem like this. I didn't get anything to cancel out here, but I don't really know that until I try. So if we look at our next one, we've got the secant squared x minus 1, and then we have secant x plus 1. So what I recognize about this, yes, it's a Pythagorean identity, but I also remember that one of my steps say to factor it if possible. And I know I can factor this because the difference of two squares. Remember, the difference of two squares breaks down to say it's a plus b times a minus b. And the way you find a and b is you take the square root of each of these. So if you can't remember how to use the difference of two squares formula, you take the square root of both of these. So the square root of this would be secant, so a would be the secant, and b would be 1. So you can break this numerator down to say that it's the secant of x plus 1 times the secant of x minus 1. So I was able to factor that first, so that's really what I did. So don't let these square root signs here confuse you. That's just my factoring process. I'm not actually taking the square root of each of these. I'm using the difference of two squares formula, which says take the square root of each of these to get your factors. Bring it back over its original denominator. And what I notice is that I have a secant of x plus 1 and a secant of x plus 1. And those will both cancel out. And so again, I can simplify this down to just a secant of x minus 1. So by factoring this, I was able to take away the denominator and leave me with just a secant x minus 1, instead of both of these secants in the numerator and the denominator. Okay, the next problem is asking me to actually solve by using some of these identities. So if I'm going to try to solve this, it says take the square root of this entire, so that square root is over all of that, when you know what x is. X is 5 times the tangent. So 5 tangent theta squared plus 25, and we're going to take the square root of that. So if I square this, it becomes 25 tangent squared theta. And I can't take the square root of this because it's a binomial, so what I want to try to do is try to simplify this. So I'm going to simplify this by actually factoring. I'm going to take out the greatest common factor, which in this problem would be a 25. I'll do that over here where I have more room. So 25 times, so if I divide both of these by 25, I'd get tangent squared theta plus 1. And that's still underneath the square root sign. Now I'm going to look at my identity sheet and try to make some sort of substitution. What I recognize, tangent squared theta plus 1, that is a Pythagorean identity. The tangent, or 1 plus the tangent squared plus 1, same thing, is the same as the secant. So I'm going to make that substitution here to make this be 25 secant squared x. So I want you to pay attention to this part right here, where I had the binomial underneath, versus just one term, the monomial. I cannot take the square root of this, because it's a binomial. I can take the square root of this because it's one term. And both of these parts of the term happen to be perfect squares. Square root of 25 is 5. Square root of secant squared is just secant. And I wrote this as an x here when it really should be a theta, because that's what we were originally using, so it should be 5 secant of theta. That's as far as I can take it. So I've solved this by plugging in what I knew x was, factoring, making the substitution then of the Pythagorean identity, and then simplifying that square root. Okay, you'll notice at the very bottom of your notes here I've got a try this problem. I want you to try to simplify this problem here. So I'm going to invite you to pause the video, take your time to try to solve this one on your own. As soon as you come up with your solution, play the video, I'll show you the steps, and see if you got the right answer. Again, I encourage you to try this on your own and not just watch me do it in the video. So again, please take a second to pause the video and try this on your own. Okay, so now that you've tried it on your own, taking a look at this, what I'm going to do first of all is I'm going to take out the greatest common factor, which is a cosine squared. So if I divide both of these by cosine squared, I end up with cosine squared of x times 1 plus tangent squared x. Now I'm going to go to my identity sheet and try to find an identity for this 1 plus the tangent squared of x. I know that that is the same as the secant squared, so I'm going to make that substitution. That's the secant squared, and we're going to times it by the cosine squared. Next thing I'm going to recognize is that these two are reciprocals. I know that secant squared x is the same as 1 over cosine squared x. So really what I'm doing here is I'm using the fact that secant of x is equal to 1 over cosine of x. I can square these to come up with this identity. So that might be something I want to add to my formula sheet too, is where I see the reciprocal identities, make a note that says you can square these as well. Like we did before in the previous, or the first problem here where we did tangent squared and cotangent squared, being sine squared over cosine or cosine squared over sine squared. Again, that's going to be an important characteristic for you to understand. So by making that substitution, I can change this into 1 over cosine squared. And so now when I multiply these together, these will actually cancel out. And I was able to simplify this all the way down to just a 1. So how did you do? Did you get it right? If you didn't, do you understand where you made your mistake? There are multiple ways to do these problems. I just chose to do it this way. You may have gotten one and did it differently. That doesn't necessarily mean that you did it wrong.